What is up, everyone? John Grimsmo here. I got a quick and dirty video for you. I got a project to do that I'm just going to bring the camera along and not spend too much time on it or whatever. Eric's working in the background, he's got music playing, so it's just how it is. So, we have a tool that we've had for like 6 months or so. Haven't done any videos on it yet just because we've been busy. I've been meaning to do videos on it. This is the vibratory tumbler from Northern Tool. It's about $800 plus shipping or whatever, and we've been using it a lot, and it's great. I love it. Once you figure out your particular requirements for media and all that stuff, it works really, really good. However, it works until it doesn't. It sort of broke the other day. Underneath, there's the motor, and then it spins a counterweighted or an eccentric shaft that sort of rotates around. I'll show you that in a minute. And the whole thing is on springs. So it does that. So this Northern Tool tumbler, it's obviously an import model, Chinese. They make American-made versions by Mr. D. Burr and some Roland or Raw or something. American versions that are probably much better made. Now, I don't want to complain and like badmouth the product because it does work. It tumbles our products very nicely. Except I gotta admit, it broke. I mean, it totally just... This is the offending part. It absolutely broke. I can't deny that. So, anybody who's thinking about getting this tumbler, I mean, just, you have to be aware that it did break for me.
It was not made in America.
Yeah, as Eric said, it was not made in America. So I don't know if it's the quality of the steel, or I'm thinking because of this weld joint right on a step, the silver part's machine, the black part's just raw steel and then powder coated. It's maybe a fracture joint right there because of the weld and because of the step. That's kind of my theory. So on the new one, I'm going to move the tab over just a 1/4 inch, and hopefully that'll alleviate the problem. And I'm going to use a much better steel. I don't know what this is, but I'm going to be using 4140. Should be a lot stronger. But yeah, so I mean, on one hand, I hate to badmouth a product that works well, but it broke. What are you going to do about it? I don't know. So if you are going to get one, Northern Tool does have a 12-month warranty feature, and I might try to warranty this product just because they need to know about it. I don't know if they'll just send the whole thing. I'm not going to send the whole tumbler back. That's stupid. But I would prefer just to get a new part. But we'll see. For now, we're going to make a new one. This is the main drive shaft. You can see a V-belt pulley. It's because the motor drives this. So it spins the shaft. Here's the axis of rotation. And it's got this huge off-center weight that just kind of goes vroom, 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 vroom. And with the springs on the tumbler, it just shakes it all around into a circular motion so that the whole thing's kind of jumping up and down. So it's kind of weird and scary when you look at it, like it's flinging this 1.25 inch bar, which is quite heavy, just flinging it around and around. Alright, so here's the broken part. You can see the main shaft just totally got shafted right there. It just tore itself apart. It didn't twist, it just sheared apart. I don't know exactly. It's like something just pulled it. It pretty much broke at a turned joint. You can see they turned this down. This is just the steel, and then they turned it down to here. So that's exactly where it broke. It's not much of a step. This is only about 90 or 0.95-ish, and this is 1 inch. But anyway, it's a fairly simple assembly. It's just got these bearings on the end. They come right off. They're metric, by the way. Everything's metric. So those come off. This comes off. That side comes off. So it's basically just a bar with 2 tabs welded to it. And it's turned. There's 2 different steps here, but it doesn't really matter. This could all be 1 step. And then a smaller step here for this guy. And then a bigger step here for this guy, and then just 1 step on this side. For some reason, they turn this oblong off center. I don't know why. I'm just going to turn it on center because I think it's stupid to have it like this. But I think it'll work. So I went to the metal store this morning and I got a 18-inch long piece of 1-inch diameter, 4140. I'm sure this is just 1018 or some garbage stuff. I doubt it's been heat treated at all or anything. Maybe, but I doubt it. So I got 4140, which is good, real good. And then I'm just gonna basically drill 2 holes, weld one there, weld one there. I don't have a good welder, so I'm gonna have to take it to my friend's house or to a shop to get it welded. But I'm gonna use my junky old lathe to turn these down. This is my awesome Tormac PCNC 1100. This is my very much less awesome Grizzly Go602 lathe, which I converted to CNC. This is my first experience with CNC. I converted this guy. You can see I use it a lot right now for storage of stuff. So I just got to clear it up. Just booted the computer up, and I really don't use this thing at all. But here's a perfect example of a good time to use it. Eventually I do want to upgrade to a proper CNC lathe. Hopefully that'll happen sooner rather than later. Alright, so like I said, I haven't run this lathe in quite a while. I've been messing with it a little bit. It seems to work okay. So I wrote a quick program that's going to face this down 1.5 inches long to a diameter of 0.781, which is the original size. And let's see if it works. I am a little hesitant, I will admit. It's just kind of nerve-wracking to trust a machine that I hardly ever use. I don't know. Here we go. Just testing my stop, make sure it works. It does. Chips are turning a little bronze, which is good. Hopefully it's not too hot for this machine. I'm doing about 1200 RPM, 10 inches per minute, 10 thou depth of cut. Radial depth of cut. Just totally guessing on those numbers. Seems to be working great. Throwing chips everywhere. Oh, I saw a bit of a hiccup there. So I feel like an idiot. Got the code wrong and it's too small now, which means this whole bar is probably garbage. Have to go to the metal store, get a new one. Crapola. I wasn't thinking. I don't know. In the program here in Mach 3, this is a wizard, which is really handy, and you can write a lot of code with this. And it's a facing wizard, so I can face, put a little radius in the corner. I wanted a 16th inch radius and start just past the part and make it 1.5 inches long. The part is 1 inch diameter starting, and I don't know why I totally spaced out, and I put this at basically 0. Negative 30 thou is past 0, so past the center line, which will clean it up perfectly. But idiot that I am, this number will completely get rid of this whole face. It'll make the X end at 0, so it's going to cut it all away. Idiot. This should have been 0.781, but I didn't because I'm an idiot. So that's crappy. I was watching it turn and turn, and I was looking at the digital readout numbers here. And this starts getting down to 0.72, 0.70, and I'm thinking, wait, it's supposed to be 0.78. This is going to be too small. So, shoot. I don't think there's another alternative, unless I made like a sleeve bushing or something. But I don't know if I'm prepared to do that right now. I think the easiest thing would just be to run to the store and get another one. It's only 5 minutes away. $10, whatever. Okay, I might just go do that. Alright, old bar right here, got my new bar in here. Round trip about 25 minutes, get to the store and back. But let's get rocking. This time getting the number correct. I've got my shield in place, works pretty good. Success! Now I stopped this at 0.8, which is bigger than I want, but just so I can confirm that I'm getting the right size here, which I'm not. I'm getting about 0.791, which is 9th smaller. If I had guessed for absolute final size, I would have been way undersized. So that's good. Now I just have to modify my offset and run it again. Yeah, about 791, I want 781. No big deal. Check it. 781 on the nose, depending on how I hold this thing. Just gonna wrap some sandpaper around there, spin it really slow, and clean it up. So the steel I'm cutting here is 4140 annealed. It's not heat treated or anything. You can buy it both ways. And the color of the chips is pretty epic. I love it. These ones are kind of a dark bronze, and these ones are just blue, like crazy awesome blue. I love it. Success! As far as all the turning goes, I think I'm all done. So I wanted to mention about this machine. I've probably had it for 5 or 6 years or something. I haven't used it much for the past 3 years. It's been completely neglected. Everything's loose and sloppy, and it needs a total overhaul, maintenance, upgrade, and all that to be any good. You can see that the surface finish is kind of terrible. It actually did better with a heavier cut than this was a really fine, like 1 thou finish cut. And it streaks and it blah blah blah. However, it's the tolerance that I need, and it works, and it's awesome. And I put a little radius in here and a little radius in here. This is where it broke on the original one, so I put a little radius in there so that it's not a hard corner. And hopefully it works. Now I just have to mill some key slot grooves on the Tormac, and then she's all done. And then I need some welding, I guess. New one, old one. Last step is just to mill these little flats for the set screws. There's 2 of them there, so I mill them right there. Turn part here, and then mill more little flats there, and then a key slot groove right there. And then take my 2 little plates like that, pop a hole in the middle, maybe chamfer this on the grinder so that it fits in there, and then get my buddy to weld it from both sides super well. Describe to me what you're doing right now, kind sir.
I am disc sanding a set of handles. Well, one handle.
Yeah. This is going to go in the video for that.
Okay. Yeah, just bringing it up to 400 grit so it can go in the tumbler.
Okay. And then after you put in the inlay, almost there, yeah. After you put in the inlay, you'll sand it again, right?
Exactly.
So, making great progress on this turned part. I gotta say that was kind of fun on the lathe. I really miss lathe work because that's how I got started in CNC, and it's sort of in my blood right from the beginning. I just wish the lathe was tighter and better and nicer and more power and more everything. So yeah, eventually soon I will hopefully upgrade to a much better lathe. If anyone is interested in buying this, I'll give you an awesome price and a complete parts list that you need to upgrade it and soup it up and make it wicked awesome. So just thought I'd put that out there real quick in case anybody's watching. I'm near Toronto, you gotta come pick it up. I'm not gonna ship this thing. But yeah, I'd sell it. Even though I used it today and I'd be kind of lost without it. So now that that's done, we move on to something I'm much more comfortable with, is working on the Tormac mill. I just gotta mill a few slots and flats, and then she bangs. So here on the mill, I've got the Tormac vise on here, just with some junky soft jaws that I made unimportant. But this is one of the jaws that Tormac sells. I guess it's called a V-block jaw. I use it sometimes, but the good thing is I can use it without even bolting it down. And it's good for holding round parts and everything. So I just put it right in there, take my rod, and unfortunately I can't really hold it from here because there's a step. So I'm just going to hold it from here and deal with any chatter or whatever. See, and the V-block is really sweet because I can just self-center. Okay, real quick. First step, doing this side. So first step is to mill that little flat, and then there's another one right there. I don't know what the angle is between the two. I'm going to have to guess. But it's just a super simple flat. So to do that, I'm going to use, I've got a Lakeshore Carbide 1/4 inch 4-flute end mill right here. And I'm just going to come in here and bzz, 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 and then mill this slot right here. Alright, back to the inlay. Eric is squidging in some Loctite 380.
Lots of it.
Lots of it, which is what Todd Begg told me to use.
It was what, like 40 or 50 bucks a bottle or something?
I think it's 25 or something, like quite expensive for glue, but whatever. Yeah, so it's black, it's goopy, it works pretty quick, huh?
Yes.
So let's get going. So Eric's going to use the arbor press. And it says it's got a pretty quick cure time, so we don't want to mess this up. Don't get it wrong.
I'm trying not to.
I heard it.
Yeah, that felt like it went in. Just make sure.
And then we can see, oh yeah, that looks pretty level. Yeah, it looks level in there. Sweet. And then it said, Eric looked up the data sheet for it. It said full cure is in 24 hours, so we're going to leave it overnight.
Yeah. But it did say full activation strength. Or full strength activation or whatever. Whoops.
Oh, good.
Lots came out though.
Well, good. We wanted it to come out. I think. Unless that means there's a bigger gap there.
There might be a slightly bigger one there, I guess.
That's okay. We'll live. At least now the gap is full of glue.
Exactly.
So
Actually wipes off.
good. So the inlay is quite a bit thicker than the pocket right now, so it's sticking up, but that gives Eric something to sand off.
Good, because I got black glue all over the micarta.
Oh, it looks great though. It's in his beard. It's
Yeah,
his
he's-
streaked beard.
Either been...
It's blood. Yeah. He's
Yeah.
got in a fight, you know.
Yeah.
Our Viking guy.
It's all that pillaging.
Awesome. So I'm just freehanding this, and it seems to be working pretty good. Using the jog pendant, moving it around. That looks about good.
The light.
Yeah, tricky, huh? I can turn this off. Just need a little flat for that set screw to flatten down on. Now I just have to guess how much to rotate it. It's probably 1/3. Ish. Yeah, it's probably 1/3. So 1/3 for rotation. So here I'm just manually writing a code that's going to basically go down, over, back, down, over, back. And instead of plunging straight down, which is not super good for the end mill, it's going to taper a little bit. Over, back, down at a taper, over, back. And it's just really simple code. Quickly go through it. M3, turn the spindle on, that RPM, coolant on, safe height of Z 2 inches, move to X0, move to Z 0.5, which is down, feed rate of 10 inches per minute, and then this just starts going through the pass. This is down and over, this is all the way over, this is back. Down and over, all the way over, back. down, over, all the way over, back. And then you see how they go 1, 2, every pass, I wrote the word pass just to define it. Every pass is a little bit deeper. And then my goal is 138. So that's all there is to that. Alright, here we go. With any handwritten code, I mean, you're pretty sure that it's going to work, but there's always that little fear in the back of your mind that it's just not going to work. So, camera's on. Let's see what happens. Awesome, looks like it worked fine. Well, that was very successful. So I've got my 2 flats milled here. I've got my slot milled here. Now, I guess I'll test fit it. I'm just using a 5/16 4 flute end mill from Lakeshore Carbide. And it should fit right in. No, it's a little tight. A lot of times the end mills are not the exact stated diameter, they're a little bit smaller. So I might have to go full depth and just open it up by hand just a tiny little bit, not a big deal. So all I have left to do is put 2 little flats on this side for the set screws, just like I did here, which is super quick and easy, and then the thing is done. The shaft anyway. Quick little tweak and now it works just perfectly. So I got my holes drilled. The last thing I'm going to do for extra awesome is I'm going to contour the corner of this so that it mates the pipe or the bar perfectly, just to create a stronger weld joint, I think. Either way, it's going to be awesome. Alright guys, we are on to the next day. I got my contoured parts. They turned out really sweet and they fit on here just perfectly. So from what I know about welding, this will make a much stronger joint because it just fits it better. There's not this big gap in between the welds, or you're not filling the gap with weld. The part's got a mechanical connection and then you weld all around it and it's supposedly much stronger. So now I'm going to drive to my friend's shop or to a different shop if he's not around and get this bad boy welded. Alright, just got back from the welding shop. She is all done. This thing got TIG welded. Quite happy with how that turned out. Might not be the most beautiful coins in the world, but should be strong enough, I hope. If not, I will have some words with them. But yeah, it looks like a good job. So it's still warm actually, like half an hour later. So yeah, now it's just a point of making sure the big counterweight fits on here with the bolt locations and all that, and then putting it all back together. Right now Eric's just chamfering the little corner where the new welds are, just for a little bit more clearance.
Yeah.
Not a big deal, quick and dirty, love it. So, we are coming up on the roughly 24-hour mark since I started working on this project. It obviously didn't take me 24 hours, but probably 6 to 10 or so of effort. And probably $25 in metal, half of which was wasted, and the welding was $40. So, you know, there's some money out of pocket and certainly some hours spent where I could have been working on more important stuff. But we are back up and running in 24 hours, and we absolutely rely on this tumbler to get knives out the door. So it's kind of no point me having spent that time making knives if I can't even tumble them and get them all finished. So yeah, Eric's just assembling right now and should get it back together. But yeah. So the turning was kind of fun, the lathe work, because I haven't done that in so long and I miss it. Looking forward to getting into a bigger, fancier lathe at some point. Not that I have a lot of turning to do, but I like it. It's fun. So that is about all there is to it. Get it back up and running, maybe do one shot of it running, make sure it works, and then that's that.
I don't work as good as a motor.
I can hear it in your voice.
I have no bearings.
But fits good, huh?
Yes.
It's gonna be awesome! So Eric is packing the bearings full of grease. I like his grease gun applicator. Well, there we go. As you can see, the tumbler works perfectly. It's been running for maybe 2 or 3 weeks now since I fixed it, and it's running like a top. Just love it. So maybe someday I'll do a review video of this with some, you know, real thoughts and tips and tricks and stuff. But it's fixed. Yay! Problem solved. All right, guys. There you have it. Thanks for watching. Bye.